All right, good day and welcome to Volume of 3D Shapes Part 2. This is Lesson 8.4b. I know what you're saying, this is probably too easy for us, so we're going to step it up a little bit and try some more difficult shapes today. Just in case you missed it, you were asleep, or you've forgotten over the course of 24 hours. We started last lesson working on finding the volume inside of a shape. How much can we fit inside of a three-dimensional shape? And it's a pretty simple concept. You can multiply the length by the width and by the depth of the shape to find the volume of anything. So if I take 20 and multiply it by 40, multiply that by 8, you can pretty simply find the area of each shape. That's, in this case, 6,400 cubic centimeters. Centimeters to the power of 3. As I mentioned last lesson, I typically find the area of the front of the shape, which in this case is a rectangle, which is 20 times 8, which is 160. And then I usually multiply that by the depth of 40. And there's a reason why I do it that way, because when you get into more complex shapes, it's easier to find the area of the front shape if it's a weird shape, especially, and then multiply it by the depth. So let's try some different shapes today and see if we can find the volume. First, let's get rid of the surface area. We don't need it, because today we're going to focus just on the volume. All right, so here we have a triangular prism, and we want to find the volume. If we can find the area of this triangle, and then times it by 20, we will find the volume of that little wedge. Now, all of you are talented enough to remember how to find the area of a triangle. We take the base, times it by the height, and divide it by 2. So remember, it's half the base times the height. So that's a half of 12 times 9. And 12 times 9 is what? 108, and half of that is 54. So the front of this is 54 squared centimeters. And then I'm going to multiply that by 20. That's the front. And I times that by 20 centimeters. So basically I've got 54 times 20. I've got 1,080. Hey, and when I multiply a centimeter squared times a centimeter, I get a centimeter to the power of 3. Remember, I add the exponents. So I've got 1080 cubic centimeters. The biggest mistake that you will make when you're doing questions like this is you, again, forget to take half of 12 times 9. Don't just take 12 times 9, because 108 is the area of a rectangle and not half of it, which is the triangle. All right, that's a triangle. Let's try a cylinder. So how do I find the volume of a cylinder? How do I find how much material will fit inside of a can that's round, like a Pringles container? So here we have a tube, it's a cylinder. If we can find the area of this circle and then times it by 40, we should have the volume of the cylinder. So let's just see if we can find the area of the circle. And we know how to do that, because if the diameter is 10, that means the radius is 5. This cylinder is kind of wonky because it's stretched out on the smartboard, so it doesn't look like a circle, but it's oval. But don't worry about it, it's a circle and it has a radius of 5. Remember, the area of a circle is pi r squared. That's 3.14 times 5, which is the radius, squared. That's 3.14 times 25, which is 78.5 centimeters squared. I now take that 78.5 and times it by 40, use your calculator, leave that in your screen, and you get 3140 as your volume. Again, that's cubic centimeters cc's. 3140 centimeters to the power of 3. Look at how easy that is. I know what you're saying. Let's try something more challenging. Okay then. Here is a parallelogram that's also a prism. I guess you would call it a parallelogramal prism. That sounds really weird. Speaking of weird, your pants are weird. All right, so let's find the area of the front parallelogram. Again, remember a parallelogram area is base times height. That means we're going to have to use this height, which is given to us here as 9. Don't use the 10. We don't need that. Don't be fooled by that. That's 9 times 14. If you don't know what that is, use your calculator. It's 126. So this whole area is 126. So let's write that in. And now I just simply multiply that by 25. And I get a volume of 3150 centimeters cubed. Yeah, I know what you're saying. That's probably too easy for us. All right, what if we have your favorite, a hexagon? We're going to need to know the apothem. We're going to need to know this height, which isn't given to us, nor is the side length. So let's add that in right now. Let's say that each of these is 12 centimeters. And let's say that this apothem, I don't know, let's go with 8 centimeters. So remember, to find the area of a hexagon, and some of you are struggled with this last unit, you have to make little triangles out of this. And in this case, you've got to make 6 identical triangles and find the area of each triangle and then times it by 6. And remember that each triangle in this case is 12 by 8. That means I take 12 and times it by 8 and then divide it by 2. Because it's half the base times the height, which we just talked about. So that is going to be basically 6 times 8. Our area is 48 centimeters squared for each of these 6 triangles. So I'm going to times that by 6. And 48 times 6 is 288 would be the area of that hexagon. And then I simply would have to times it by the length. This has no length. Let's just say that the length is, I don't know, 50 centimeters, because it didn't have a length. To find the volume of this, I would just take 288 and times it by the length, which in this case we just said is 50. Luckily, I've got 288 in my calculator screen. That would be 14,400 centimeters cubed. 14,400 cubic centimeters, or cc's, which is also the equivalent of 14,400 milliliters, because a centimeter cubed is also 1 milliliter if you're talking liquids. All right, so that brings us to the end of complex shapes. We've got some weird shapes. Today's worksheet is going to have some weird shapes like this, and you got to try and find out how much space is involved. Our next lesson is going to be even more complex shapes, when we've got shapes with other shapes, and even maybe some cutouts. So try today's worksheet. Good luck, and we will talk to you soon.